Okay, we have looked at limits at infinity, and that's x approaching infinity and x approaching net infinity. We've looked at them by charts, and we looked at them by graphs. Charts and graphs are good ways to understand what's going on, good ways to check your answer, but they are not ways you should find your answer. So we have a fact here. If r is a positive rational number and c is any real number, then the limit as x goes to infinity of c over x the r is 0. Furthermore, if x the r is defined when x is less than 0, then the limit as x goes to negative infinity of c over x the r is 0. So the second sentence about furthermore, if x the r is defined when x is less than 0, blah, 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 that second sentence is trying to cover our mathematical rear ends about imaginary numbers. Remember, we're never, ever, ever going to use imaginary numbers in this class. So if x is approaching negative infinity, x is negative, there's potential for imaginary numbers. We aren't doing imaginary numbers. All that being said, what this means is this, that limits of the form of constant over infinity, plus or minus infinity, raised to any sort of exponent. Constant over plus or minus infinity, go to 0. Now, horrible, horrible, horrible notation. I shouldn't substitute in infinity because infinity is not a number and you shouldn't treat it as a number. So now that I've said we should never substitute infinity because infinity is not a number, we shouldn't substitute negative infinity because negative infinity is not a number. Now that I've said that we should never do it, we're going to do it anyway, and we just won't tell anybody about it. But if you allow yourself to think substitution for a moment, and I replace that x with infinity or negative infinity, and then it doesn't matter if I use any sort of exponent, whether it's a radical or square or whatnot, infinity, square root of infinity is infinity, infinity squared is infinity, and as long as things are defined, negative infinity, the cube root of negative infinity is still negative infinity cubed is negative infinity, that once I have this infinity in the denominator, and I have a constant over infinity or negative infinity, it always goes to 0. So, fact. All the limit laws stated earlier are true when the limit as x approaches a is replaced by the limit as x approaches infinity or the limit as x approaches negative infinity. So all of our limit laws that we had before still true, meaning that I can do this. Because basically I have a new form right now, that the form constant over infinity or negative infinity goes to 0. So I can incorporate that new form into my problem. So technically, I can do this, that I can break this guy up into 4 different limits. Then I can do each one of those guys. Well, this is a limit of a constant. It doesn't matter what x is approaching. The limit of a constant is a constant. So this is 3. This next limit has your new form. Constant over infinity. That is going to go to 0. So minus 0. Down here, the limit as x goes to infinity of 4. The limit of a constant, it's the constant. And this guy now is our new form. Constant over infinity. Constant over infinity goes to 0. So I have plus 0 for 3/4. And that's done. Now on a test or quiz, all I would be looking for is that right there. That is the complete solution. You show me that, you've got full credit. You don't have to show me, oh, constant over infinity goes to 0. I'm expecting that to be in your head. You show me this work, you've got the answer. So I know now how to deal with limits at infinity. If it's just a plain number like 3 or 4, those are just constants, so that doesn't change. Or I know about constant over infinity. This next guy here, I don't know how to deal with it directly. This does not have the known form constant over infinity. That's the only form I really know about when I'm doing limits at infinity. And so what I'm going to do, I'm going to do a little rewriting here first. And so that's x to the 1/3 over 4 minus x to the 1/2. What I'm going to do when I don't have that form to create the desired form, I'm going to divide all terms by x to the largest exponent. I'm running out of room here. I should have written smaller or given myself more room. So that's the limit as x goes to infinity of 3 over x to the 1/2 minus x to the 1/3 over x to the 1/2 over 4 over x to the 1/2 minus x to the 1/2 over x to the 1/2. So I divide everybody by x to the largest exponent, and in this case, the largest exponent is x to the 1/2. Now I'm going to simplify. And so that's the limit as x goes to infinity of 3 over x to the 1/2 minus subtracting my exponents here. Remember, in a fraction, you subtract your exponents, and so that's going to be 1 over x to the 1/6. 1/2 minus 3 is 1/6. Over 4 over x to the 1/2 minus 1. And now I have forms that I know. The 1's going to stay the 1, and everything else is going to go to 0 because everything else is constant over infinity. If I allow myself to think substitution just for a moment, all those x's, whether it be x to the 1/2, x to the 1/6, the square root of infinity is infinity, the 6th root of infinity is infinity, all those x's, if I allow myself to think substitution, all those x's would become infinity, all of those would be constant over infinity, and so I'm going to have not 3, I'm going to have 0 minus 0 over 0 minus 1, 0 over negative 1, 4, 0. And there's that answer. Okay, here's a little algebra review for you. Recall the square root of x squared officially is the absolute value of x. Officially because mathematicians wanted the square root to be a function, so it needs to be just one answer. Yes, both 3 and negative 3 are, when we square them, gives us 9. But by definition, the square root of 9 is 3. The square root of 9 is not negative 3, that we always want things positive. And so officially, to make sure that my square root is always positive, we throw absolute value around it. And then you have a definition of absolute value. Absolute value of x is either negative x if x is less than 0, or it's positive x if x is greater than or equal to 0. That there is an official definition of absolute value. And you think about it for a minute, the absolute value of negative 3 is negative negative 3, which is what this definition is saying. Negative negative 3, which is 3. We're going to use this concept that the square root of x squared is the absolute value of x, and then what absolute value is. We're going to use that in this next problem, which we will start in the next video.